Hello and welcome. Today, we're going to get into one of the most fundamental ideas in all of programming, how we teach a computer to make a choice. I mean, have you ever really thought about it? When you tap a button on your phone or type in a password, how does the software know what to do? How does it know if your password is right or wrong? Or whether you just won the level or you lost? Well, the secret is that even the most complicated software you can imagine is really just built on countless tiny little decisions, just simple questions with a clear yes or no answer. To really get our heads around how a computer thinks, let's just start with a super simple decision that, we've all made. Picture this. You've got exactly 22 pounds in your pocket. This is the exact kind of question a program asks itself. It looks at the item's price and compares it to the money you have. The result of that one comparison, is it a yes or a no, true or false, is what decides everything that happens next. So, how do we actually visualize a choice like this? Well, let's map it out. Okay, so what you're looking at here is a flowchart. See that diamond shape in the middle? That's our big decision point. It's asking the question, is the cost less than 22? And from there, you can see the path splits. You've got a yes path and a no path. It's basically a perfect picture of a fork in the road. Now, that question inside the diamond, cost less than 22, actually has a technical name. We call it a condition. And a condition is just a test that can only, and I mean only, have two possible outcomes, true or false. There's absolutely no maybe about it. And this whole process, using that condition to figure out which path to go down, that is what we call selection. The program is literally selecting the right chunk of code to run, all based on whether that condition was met or not. So, to build these conditions, we use a set of tools called comparison operators. These are the little symbols that let us ask all the important questions like, is this number bigger than that one? Are these two things exactly equal? Or is this thing not equal to that other thing? All right, so we've got our visual map. Now let's see how this actually translates into the language a computer really understands. In this case, Python code. And look at how perfectly our flowchart logic translates into code. That diamond-shaped question, it becomes an if statement. The yes path is the bit of code right after the if, and the no path, that becomes the else block. It is the exact same logic, just written in a way the computer can actually run with. Okay, so an if statement is great for making a decision right here, right now. But what if we need to remember the result of that decision for later in the program? For that, programmers use a clever little trick called a flag. You can think of it just like a referee's flag in a soccer match. It goes up to signal that something important has happened, and we can check on it later. So we can set this flag to a starting position. For example, we might just assume that an event hasn't happened yet, so we'll set our flag to false right at the beginning. This type of variable, the kind that can only ever be true or false, is called a Boolean. It's the simplest possible way to store the answer to any yes or no question. And this is so fundamental for everything, from a game checking if a player is still alive to an app remembering if you have dark mode turned on. Boolean flags are basically the memory of our program's decisions. But let's be honest, life isn't always a simple yes or no, right? Sometimes there are way more than two possible answers. So what happens when we're not just checking if a number is high or low, but if it's exactly 1, or maybe it's 2, or maybe it's 3? A simple if-else statement only gives us two paths. How in the world do we handle more? Let's say we ask a user to name a primary color. We need to check if their answer is red, or if it's blue, or if it's yellow. This kind of problem needs a structure that can handle way more than just two outcomes. And this is where elif comes to the rescue. It's really just short for else if. What it lets us do is chain a bunch of conditions together. The program checks the first if. If that's not true, it jumps to the first elif. If that's also false, it moves to the next elif, and on down the line. It's a really clean way to build a decision with multiple paths. Now, writing code is a game of precision, so let's take a quick look at some of the most common tripwires so you can avoid them from the get-go. Here's the deal. Unlike human language, where we can be a little sloppy and people still get what we mean, programming languages are incredibly strict. Forgetting a single colon or using the wrong capitalization can bring your entire program to a screeching halt. The computer needs you to be precise. Here are some of the absolute classics. Using a capital I instead of a lowercase I. Forgetting the colon at the end of the line, that is a huge one. And this one gets everybody. Mixing up the single equal sign, which assigns a value, with the double equal sign which compares two values. And this slide points out a few more really critical rules. First up, indentation. In Python, that space at the beginning of the line isn't just for looks. It's how the language knows which code belongs inside the if and which belongs to the else. Second, remember Python's special keyword is the short version, elif, not elsif. And finally, you can only have one else block at the very end to catch everything else. So here's the crucial point, the main takeaway. Everything we've talked about, from a simple choice about money to a really complex chain of decisions, it all starts with this one simple building block. The if statement is what gives code the power to react to the world. So there you have it. That's the core of how computers make choices. Now that you understand the basic building block, here's a thought. What's the very first decision you would want to teach a computer to make? It's a pretty powerful idea. Thanks for tuning in.